Students, I'm going to explain that redemption brain Java as promised. So this first problem says right here, we want to find the measure of JLI. So we go like this, JLI. We have to go in that exact order. But as you can see, we are missing an arc right here. And we're also missing something here. And we're also missing something here. So start with what you have. We do have a diameter. Remember diameter, trace, stretch it out, sweep the 180. That's 180. We can add so I'm going to do 180 minus 99. And I get 81. So this arc here is 81. We know that circles add up to 360. So to get the green, we're simply going to do 360 minus 81. And we get our arc measure of JLI is 279. Watch out for your diameters. Given the area of a circle is 100 pi, find the circumference in exact terms. Exact means pi form. So we start with area. Apple pie is really, really good. And we are told the area is 100 pi. So I have 100 pi equals pi parentheses r squared. We want to solve for what we can. We're going to have r squared equals 100. The opposite of squaring is square rooting. That means our circle radius is now 10, square root of 100. We come over here, we want the circumference. C, d pi, I see d pi. We need the diameter. So if the radius is 10, the diameter is going to be 20 centimeters. So exact term is going to be 20 pi centimeters, and you're done. Area would be squared centimeters, but circumference is only length around, so therefore it's only one dimension. All right, this one, several of you found it super annoying. Let's start with the obvious. One, we have a 180 here. So we sweep our 180 here, and then we have another 180 going this way. This is an inscribed angle. Angle equals half the arc. So if this is 54, this arc has to be double. So it's 108. You're like, what else can I find? If this is 180, we take 180 minus 108, and we're going to get this as 72. This is an inscribed angle. It grabs that 72, which means back here is 36. And then if you go this way, this is inscribed and it's grabbing the 108. So that means back here is 54. And if you look at this black angle, the black angle grabs the 180. That means back here it's inscribed, it's 90. super important. This here in the middle is not 72. Not. And the reason why it's not is this point right here is not the center of the circle. So you can't pull down the 72. So these four angles, as well as this arc and this arc, you actually can't find. So keep in mind, when I say all possible, doesn't mean all is possible. Right here, graph the circle. So we start with the circle equation. X minus h parentheses squared, y minus k parentheses squared equals radius squared. And you pull out your h, your k, and your radius. So our h, notice it swapped the sign, which means our original h had to be -4. K did not swap the sign, so that's +3. That is the center of your circle. And then we have r squared is 9. So your radius is therefore the square root of 9, which is 3. There's your center, and then go 3 up, 3 to the right, 3 down. That's how you graph a circle. It says write the equation of a circle. Stop right there. Let's actually write that. And we are told you have a center, which means your h is right there. Your k goes right there. But we're missing the radius. Look what we're given. We're given the circumference equals 12 pi meters. C equals d pi, which means if you draw a picture here, your diameter is 12. That would make your radius to be 6. So now we clean it up a bit. It's x minus h, which is 0, plus y minus k, which is -3, equals 6 squared. You clean it up. X minus nothing is just x, so I have x squared. Double negative makes a positive. This is y plus 3 squared equals 36. And you are done. Making sense, Haley? Okay. Last one. Let's start with the blank page so you can see what this looked like. X is this piece right here. And you had 14, which is the radius, and 11.6, which is right here. And your goal is to find x. And you're like, So here's a basic rule of thumb. If you don't know what to do, look for or make a right triangle. All radii are equal. So see that 14? I can swing that 14 around and connect it right there. Now, that's 14. Now I have myself a right triangle. I can solve for the blue squiggle, which I'm going to call y. So just so you can see it, that's 14, 11.6, blue squiggle, we're going to call that y. And Pythagorean Theorem, leg squared plus leg squared equals hypo squared. So I'm going to have y squared, 11.6 squared, 14 squared. If I were to solve for y here, y is going to equal giant square root of 14 squared minus 11.6 squared. Square root. So we get 7.8. That is not your final answer. 7.8, that little piece there is 7.8. We're looking for this right here. If you take, see these x's? I'd like you to finger pinch the x's, finger pinch them. Put your finger there. Haley, what's this distance, ma'am? Put your fingers there. See the x? See the x? Good. Ready? Aha! You realize that distance between the x's is 14. You are correct. So to get your red squiggle, 14 minus 7.8. Borrowing, that's 13. And that's now a 10. So that means your x is 6.2.